Hey guys, this is a video for your Spiral 2 review. We're going to start off with looking at functions, domain, and range. Our first problem has a couple parts. The first part asks us to sketch the graph of a function whose domain is -4, 3, 5, 9, and whose range is -6, 4, 5, and -2. I don't ask for you to line these up in any specific way. So there are lots of ways that you could do this. I'm going to go with the most straightforward, which is to pair these values up with each other in order. And again, this is not the only way, or necessarily even the best way to do this. This is just a way to pair these up. Okay, so first up we've got the point -4, -6. So that's going back 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. My second point, based on how I line these up, would be 3, 4. So it's going over 3 and up 4. My third point, based on how I line these up, is 5, 5. So that's going over 5 and up 5. And my last point, based on how I line these up, is 9, -2. And 9, -2, that's 2, 4, 6, 8, 9, and down 2. The bottom part of this question asks, what one point could we add to make this function no longer a function? Okay, to make this function no longer a function, I know that it needs to fail the vertical line test. In other words, I need another point at any one of these x values. I'm going to kind of arbitrarily choose the point -4, 0, and that fails the vertical line test, because if I try to draw a vertical line now through here, I hit 2 points instead of 1 point. You could have added a value at any existing x value, either somewhere along 3, 5, that's not 5, that would be 5, or 9 to the same effect. For our second graph, it asks us to sketch a graph of a relation whose domain is -infinity to infinity. As soon as I see that, I know it has to go off in both directions, and whose range is 3 to infinity. What that means to me is that we're starting at a value of 3, and that we're going up at some point forever. Okay, aside from these two conditions, it doesn't really matter what my graph looks like, in part because it says relation, and in part because anything that I do that kind of goes off and up in both directions and hits a height of 3 at least once is going to make this true. So this has a domain going to -infinity and going to +infinity. I showed that by having this run off my graph and including arrows. It starts with a lowest point at 3. There's my point 0, 3. That can be anywhere at 3 or multiple places at 3. And then it's continuing up off the graph, so we assume that's going to positive infinity. Must this relation be a function? Based on how I drew this, it passes the vertical line test. So this relation is actually a function. But what if I did something like this? I'm going to make this a bolder color so we can see it a little bit easier. So we keep going up and to the left, but now I do some kind of a loopy thing where I hit 3 a few times. And if I take a look at this, this fulfills my conditions. Its domain is -infinity to infinity. It goes off in both directions. So it goes off here and goes off here. its range starts at 3, that's this line here, and goes up forever. But in this case, this is not a function because it fails the vertical line test. As soon as I try to draw lines vertically through those loops, I hit more than one place. For our third question, you're asked to do some composition. And at first, we're trying to find g of f of 4. Okay, so let's do that. So g of f of 4, first I'm going to find f of 4, which is 5 over 2 times 4 plus 1, which is 5/9. That means instead of f of 4, I can write 5/9. G of 5/9 is going to be the square root of 1 minus 5/9, which is the square root of 1 minus 5/9, so that's 9/9 minus 5/9 is 4/9. And since the square root of 4/9, I can square root the top and the bottom. That comes out to be 2/3. That came out kind of nice, actually. For number 8, I have that awful notation. We know now that this means f of g of, oh good, this stuff on the inside, x squared plus 1. Let's find g of x squared plus 1 first. That means I'm going to use g of x, 1 minus, and instead of x, I'm going to plug in x squared plus 1. Okay. My 1 and 1 in this case are going to cancel out, leave me with the square root of negative x squared, which is never going to have a real solution, but we're okay with that for the moment, because all we're doing is taking this and plugging that in here. So f of the square root of negative x squared, and when I do that, I get 5 over 2 times the square root of negative x squared plus 1. Again, this is not something that would have any real solutions or any real values, but that's okay. That's not what you're asked to judge here. You're just plugging some stuff in. For our next problem, I'm given a table, and I've got to find g of h of f of g of 2. Oof! We know we have to work from the inside out. So I'm going to find g of 2 first. G of 2 means I'm looking where x is 2 at the function g. G of 2 is equal to 2. I'm going to rewrite this with that in place. So g of h of f of, instead of g of 2, I wrote 2. Okay, next layer out, I'm going to look at f of 2. That's looking here. So f of 2, I'm looking where x is 2 at the value of f, which is also 2. That's kind of nice. So now we've got g of h of, instead of f of 2, I'm going to write 2 because that's the value of f of 2. Next layer, I'm going to look at h of 2. H of 2, so I'm looking for x is 2, down at the value of h, which is 3. H of 2, that's an h, is equal to 3. Okay? So my last thing is g of 3. And g of 3, if I take a look at where x is 3, g is also 3. My final answer for this is 3. The last problem on this page is also looking at the table, and this time I'm trying to find 2 times f of g of h of 0 and then plus 3. Okay, I'm going to do the same exact thing, but I'm going to work from the inside. Oh wait, that's exactly the same thing as I did last time. H of 0, look where x is 0, h is 1. Okay, so 2f of g of, instead of h of 0, I'm going to write 1 plus 3. Next inside piece, g of 1. Look where x is 1, down at g, and I get 2. So g of 1 is 2. 2 times f of 2 plus 3. Almost done. Next layer, I'm going to find f of 2, where x is 2, f of x is also 2. So f of 2 is 2. And now I just have to evaluate this last piece. 2 times 2 plus 3 is 7. Okay, for these guys, we're looking at trying to approach them from the sake of looking at how a couple points would transform. For the line, I might use 2. I'll start off with 0, 1, and 1, 3. For the parabola, I might use those 3 points because they're easy to find. Increase the thickness of my marker a little bit. Okay. I'm going to work from the inside out, and I'm going to zoom out a little bit. So for the point 1, 3, the first instruction I see is the inside, x minus 1. To me, that means I'm moving right 1, or I'm adding 1 to the x coordinate. And if I move that right 1, it becomes 2, 3. We do have to remember that working with the x coordinates, things go in the opposite directions. So we're looking at right for minus 1. Similarly, for the 2 times the quantity of this, what this does is compress the graph, and it pulls points in. So I'm going to divide my x coordinate by 2 because I'm multiplying by 2. So 2, 3 becomes 1, 3 again. That's kind of weird. Okay, third step. We're going to go another step out. And here I've got negative 3 times this function. We know the function represents height. This is negative 3 times the height of this function at this point. Or I can say that I'm multiplying y by negative 3, and that leaves me with 1, negative 9. That's the last transformation in this case, and that's where this point moves, which is totally way off my graph. My second point here, I'm going to use the same process. I'm going to zoom out a little bit again. So we're starting with the point 0, 1. I'm going to go right 1, and that's going to become 1, 1. I'm going to divide the x coordinate by 2, and that's going to become 1/2, 1. And I'm going to multiply the y coordinate by negative 3. And that's going to become 1/2, negative 3. These are my 2 new points to represent this line. I'm going to do the best I can to show where that is. So there's 1/2, negative 3. And to get to 1, negative 9, there's 4, 5, 6, 7, 8, 9. It'd be down here. My new line is going to be really steep, really negative, and go through those places. Wow, that's an awesome line. It's actually a little bit easier to do parabolas, and part of that's because of we're more comfortable with the shape having 3 points, and part of that is because lines are a little bit wonky when trying to put these things together. So I'm going to start with my 3 points, and that's going to be negative 2, negative 2. That's going to be 2, negative 2. And that's going to be 0, 2 for the vertex. And I'm going to start with my transformations from the inside out again. Okay. Minus 1 on the inside means that the x coordinates of each one are going to be increased by 1. So we're going to go right 1 unit. And that's going to make this negative 1 comma negative 2. Going to make this one 3 comma negative 2. And going to make this one 1 comma 2. So far we've taken the inside piece and just moved 1 to the right. There's no x multiplier here, so I'm going to move to the next thing, which is multiply on the outside. And here we've got a negative, which means that my y coordinates are going to multiply by negative 1. This is going to cause a flip to happen. And if I do this, I got negative 1, and then negative 1 times negative 2 is positive 2. I'm going to have 3, and then negative 2 times negative 1 is positive 2. And for my vertex point, I'm going to have 1, and then 2 times negative 1 is negative 2. Okay? And finally, we're going to move all the way on the outside, and the minus 3 at the end means we're going down 3. Again, I'd like to point out that if you're dealing with the y coordinates, the modifications are in the direction that you expect. X coordinates are in the opposite direction of what you expect. Okay? And looking at this, down 3, that's my last red point. We've got negative 1, 2 minus 3 is negative 1. That's my first point. We're going to have 3 comma negative 5. That's my second point. Sorry, 2 minus 1 is not negative 5. 2 minus 3 is not negative 5. 2 minus 3 is negative 1. And then here we're going to have 1. Negative 2 minus 3 is negative 5. Whew. These are my 3 points. 1 comma negative 5 is going to be here. 3 comma negative 1 is going to be here. And negative 1 comma negative 1 is going to be here. It's going to look something like this. It looks like it's been moved over a little bit and flipped upside down. I'd like you to note that in both of these I used some words to explain the transformations that I used. I also showed step by step the math I was doing. You absolutely need the words, and it's helpful to have the step by step work to show, but that's not as necessary.